Okay, so let's discuss a question from fatigue basically. So here you have a steel link which is subjected to both static and dynamic loading, and that's why you have a mean and alternating. So what is given is that there are two engineers. One engineer uses a value of 10 power 7 cycles of endurance strength, whereas another uses a 10 power 5 cycle endurance strength. So, and then based on this, if they use a Goodman approach, which will be giving a higher factor of safety. So first of all, you should know how your endurance strength, or your the stress amplitude at the time of a failure relates with the number of cycles. So this is something, a classical SN curve. It looks like this. So 10 power 7 more or less it becomes flat. That is, beyond 10 power 7 it will have a constant value of SN, constant value of stress amplitude. Okay, so beyond 10 power 7, if I use a value lesser than this, alternating value of lesser than this, it will be safe. And 10 power 5 will be a value close to this. So if you are designing for 10 power 5, you will have a higher endurance strength than 10 power 7. So that is one thing. So 10 power 7 value of endurance strength will be higher. That is from the curve directly. That is, if you want to design for 10 power more than 10 power 5 cycles, okay, if and beyond that, if it fails, then you have to use a higher, okay, endurance strength. So that this is clear from the SN curve. Now if from the Goodman approach, if you are designing it, so on the x-axis you have the mean stress, okay, and the limit for that is UTS. On the x-axis, on the y-axis, you are plotting variable stresses. That is, given a stress, you will find out a stress history. You will find out the mean stress, which you will plot on the x-axis. On the y-axis, you will be plotting variable stress. So here you have an endurance strength. So engineer A uses a 10 power 7 cycle, and that has a value of a lesser value, whereas an engineer B uses an endurance strength value 10 power 5, which is a higher value. Okay, so if you draw a line joining endurance strength and UTS, that is your Goodman line. So for B, the line B will be at the more outer, and line A will be something like this. Line A drawn by Goodman line drawn by engineer A, and B will be like this. So obviously, because B has a higher value, so if I take a point here, a stress, let's say you have a mean stress and the endurance value and the alternating value such that here, so this value will have a higher factor of safety, less chance of failure according to B than A. And the other way of saying it is, if I take a value between this line, this will fail, this point will fail by A. According to engineer A it will fail, but according to B it will be pass. So B provides a higher factor of safety. So higher factor of safety means the lower chance of failure, right? So A is like more conservative, you can say. B is or the other way of saying it, again the conservative word itself is, but you can look by taking a point here. Let's say this point will fail according to B, but will fail according to A, but will pass according to B. So B provides basically a higher factor of safety. Okay, so this is an interesting question which you have to decide. So you have to use always SN as well as the Goodman diagram as well as the SN curve into your consideration. Okay, so if you are using a higher endurance value, that means you are providing a more factor of safety. So engineer B provides a more factor of safety. Thank you.